Welcome to Chem Help ASAP. We're going to talk about how we think of the octet rule for atoms that are found in molecules. As organic chemists, we're not going to see atoms simply floating around as atoms. They're always going to be incorporated in molecules. So we have to recognize when atoms satisfy the octet rule when they're part of a molecule. Okay, so when we see atoms in molecules, there are going to be two ways that we're going to encounter the electrons. One, we're going to see the electrons in bonds, and we show our bonds as lines, typically in our Lewis dot structures and other representations of molecules. Each bond consists of two electrons. There's another way that we show electrons. We show electrons in lone pairs. Lone pairs are simply two dots. Those two dots represent two electrons. So for a molecule to satisfy the octet rule, it needs some combination of four bonds and or four lone pairs, just in combination. So let's walk through these simple molecules, all of which satisfy the octet rule. Let's prove to ourselves that they do indeed satisfy the octet rule. So the first structure, this is a molecule called methane, and we're going to focus on the carbon in this molecule. This carbon has four bonds, has four lines drawn to it, so that's four bonds. It has no dots around it, no lone pairs, and four bonds, two electrons each. That's a total of 8 electrons. Great. Okay, the next molecule is ammonia. It's not an organic molecule, but we'll see it quite a bit in organic chemistry. This nitrogen has 3 bonds drawn to it. There is a lone pair. There are 2 dots. That counts as 1 lone pair. So we have a combination of 4 lone pairs and or bonds, and that total of 4 gives us 8 electrons. Hydrogen chloride, another non-organic molecule, but we'll see HCl quite a bit in our studies of organic chemistry. The chlorine has 1 bond. It has 3 lone pairs. That's 4 of these bonds and or pairs, and that gives us 8 electrons. Note that this is chlorine. This is a third row element, but we can still very often apply the octet rule to chlorine. The last molecule is formaldehyde. Formaldehyde has 2 second row elements, a carbon and an oxygen. We'll handle the carbon first. The carbon has 4 lines to it. Note that this is a double bond. Consists of 2 lines. Each line is 2 electrons. So that's 4 lines. That's 4 bonds. No lone pairs on carbon. That gives a total electron count of 8. And the oxygen has that same double bond that counts as 2 bonds. It has 2 lone pairs, 4 dots, and that counts as 8 electrons. So indeed, all these atoms do satisfy the octet rule, and for stable organic molecules, almost always our atoms will indeed follow the octet rule.